Hi, I'm Shannon Seaver. We're looking today at systems of equations. This is section 3 of the 7th chapter of our text. On our agenda, we're going to decide whether an ordered pair is a solution of a linear system. We're going to solve linear systems by graphing, and we're also going to solve them by substitution. So first of all, I want to look at a system of equations, and what is that? Well, a system of equations are at least two or more equations, such as this right here. 3, 4 is a solution to this system because 3 and 4, x as 3, y as 4, if I were to substitute them into each equation, it will satisfy both equations. So look at the first equation. I have x plus y equals 7. I substituted 3 in for x, 4 in for y, and 3 plus 4 equals 7, so this is satisfied. On the second one, same thing. I substituted 3 in for x, 4 in for y. 3 minus 4 is -1, so this is also true. Therefore, 3, 4 is a solution to both lines. So when do we determine if an ordered pair is a solution to a system? We really need to test it in both lines. So what I'm going to do right now is I'm going to take this ordered pair, number 1, 2, and put it into both lines. We're going to substitute it in. So 2 times 1 minus 3 times 2 equals -4. So we have 2 and minus 6 equals -4. And -4 equals -4. This is true. So we know it works for the first one, but does it work for the second one? Let's check. 2 times 1 plus 2 equals 4. 2 plus 2, well, yep, that one works too. So this is a solution to our set. Okay? Now I want you to take a time to pause the video and try it on your own and come back and check your work. Okay, in this one, we found that it works for the first solution, for the first line, but not for the second line. So therefore, -4, 3 is not a solution to both systems. It has to work for both in order for it to be a solution of a system. Now, let's talk about solving a system by graphing. Really, when we're finding a solution for a system of equations, we're looking at where they cross, where the two lines intersect. So let's graph both of these lines, and notice that we have x and y on the left side of the line, of the equation. Therefore, it will be easier for me to solve by intercept. Okay, so if I solve by intercept and I put in 0 for y, the y cancels out, so we'll have x equals 2. If I put in 0 for x, then I'll have 2y equals 2 or y equals 1. So I'm going to put both those points on my axis right now. So x equals 2 we have right here, and y equals 1 right here. I'm going to connect those lines, and I'm going to extend them out. They need to be as far out as I can on this coordinate system. So I'm going to continue this slope. We got a rise of 2 and a run of 1. So we're going to go 2, 1, 2, 1, 2, 1, and just continue it out. So I have a nice straight line. Now, one of the things you need to know when you're doing this on your own is you really need a straight edge, because if you don't, your point may not end up on the exact point where they cross on your coordinate system. So it's very important that you use a straight edge when doing this. And now I'm doing this on the screen, so it's going to be very difficult for me to make a straight edge, but just know that you need to do that when you are doing this. See, as I said, it's not perfect. Okay, so let's try the second one. If I put in 0 for y, the 2y disappears, so I have x equals 6. And then if I put 0 in for x, I have minus 2y equals 6. And if I divide by -2, I have y equals -3. So I'm going to put a point at -3 and a point at 6. Here we are. Now, once again, it's important for me to use a straight edge as much as I can. Oops. So it looks as if our point, and like I said, this is not a very good line, it looks like it should be at 4, -1. Now we can check that to make sure that that is indeed the point. So let's put it into our equation. 4 plus 2 times -1 equals 2. 4 minus 2 equals 2. 2 equals 2. So that works for the first one for sure. Now let's try it again. 4 minus 2 times -1 equals 6. Yes, this is going to work. So 6 equals 6. So that is indeed the solution to our set. So the solution to our set is 4, -1. Now I want you to pause the video and try this one on your own and come back and check your work. Okay, so on this one, we found that -3, 4 is the solution to our set. And we checked it, and it worked for both equations, so that is the solution where it's the point of intersection between the two lines. Okay, so now I want to talk about solving a system by substitution. There are several steps involved, and you may want to write these down. To solve by substitution, you first need to solve either equation for one of the variables. So it'll be like either y equals something or x equals something. If one of them's already solved for one of the variables, you can skip the step. You're going to substitute the expression from step 1 into the other equation. This will result in an equation in one variable, so you won't have the other equation in there anymore. You're going to solve the equation containing the one variable. Then you'll back substitute that answer into the very first equation from step 1. Then you'll check to make sure that your answer works for both lines in the system. So this is a lot to imagine, but I'm going to show you exactly how to do this on the next screen. Here we have y equals -1 or -x plus minus 1, and 4x minus 3y equals 24. Notice that this is already solved for y. So since that is the case, I can skip step 1. Now what I'm going to do is take this entire part right here and substitute that in for y, because we know that y equals -x minus 1. So I will have 4x minus 3 times -x minus 1 equals 24. Okay, so we need to simplify this and solve for x. We have 4x, and we're going to distribute that -3 to both of these. So I'll have -3 times -x, that'll be a positive 3x, and -3 times -1, that'll be a positive 3, equals 24. So I have 4x plus 3x, that is 7x, plus 3 equals 24. Now we'll subtract 3 from both sides, and I have 7x equals 21. Divide by 7, I have x equals 3. Okay? Now we know what x is. So we're going to take this and back substitute it into our original equation. So it'll be y equals -3 minus 1. Well, -3 minus 1, sorry, I got ahead of myself there for a second, is -4. So that is my y part. So the solution to this set is 3, -4. Okay, that is your solution. Now, we want to check to make sure that we did this right. We'll put it back into both equations and check. So if y is -4 equal to -3 minus 1, -4 equals -4, that one checks. Now let's try the other one. 4 times 3 minus 3 times -4 equals 24. Well, 12 plus 12, yep, that's 24 equals 24, so it works for both systems. We know that it works. This is indeed where they intersect. Now I'm going to pause the video, and I'm going to give you guys a chance to do this, and then come back and check your work. Okay, so for the solution for this set was 611. Hopefully that is what you got. If you have any questions about this, please bring it to class tomorrow. Thanks.